So this next modeling exercise, which I will attempt to share with you in successive stages by posting it all throughout, is going to reinforce some of the material we saw yesterday on communicable processes, and it'll be focused on communicable disease. But it's going to do so in a way that will also highlight some additional features. Unlike yesterday, we will have a non-unity chance of transmission. In other words, there'll be lots of exposures where no transmission takes place, and we'll see how those are easily taken into account, but you need a bit of mechanism. Secondly, we will have a hierarchical context. Often we deal with nested contexts of, individuals and families and neighborhoods and in cities. And taking this nested context into account was one of the ability to take it into account was one of the advantages I noted of agent-based modeling. It's the ability to capture things at multiple levels of scale, some of which are associated with different processes, many of which are almost always associated with different emergent patterns. So we will see how we can take that emergent those different levels of context into account, although the model we'll be dealing with is a three-level model: main, cities or farms as you see fit, and then individuals. We'll see how we can summarize things at those levels, how we can keep track of context at those levels. And that could be really useful when comparing, say, against the results of statistical instruments, say, or hierarchical linear models or other models where you have some mixed effects in place, some factors operating at the higher level and some at the individual level. Okay? Excuse me. We also will be using this model to illustrate several additional features, including the use of parameter variation experiments to see how a model's behavior varies, how robust it is in light of stochastics within the model, and in the light of parameter variation of model parameters. We also will use this model as a vehicle for looking at intervention strategies and implementing interventions. Okay? So those are before us. We'll see what we can get done this afternoon. It's possible we'll start some of it tomorrow. We'll finish up some of it tomorrow. Okay? So that's the plan. So I'd like you, therefore, to clear your slate. If you could close all your models, that would be great. And now, I would like you to create a new model. Just as a reminder, you do this by File, New Model, right? Okay? And we're going to call this Hierarchical Infection Transmission, and I'm going to give it a version number, V1. The units of this, ladies and gentlemen, will be days. The time units will be days, okay? And just so I can share it with you very easily, I'm going to put it over here in a folder for this boot camp, okay? And I'm going to try to post this every few minutes, okay? Okay, so ladies and gentlemen, we've made this model time unit days, and we're going to say finish here. That will create our model. This model, initially has a main class, no person class, right? Simulation. Okay, so next, I would like you to go add a person class. We've gone through this exercise many times together. So we'll do new, off the model, new agent type, and we'll make it a person, right? Person. Okay. Okay, now, for this person, we are going to lend them a representation that is the one with shape body. It's that representation as a person. We've used that many times. It's this one down here in pictures, person, and we'll drag it into the person. We've used that quite a few times, right? Okay.
It's in the palette, right?
It's in the palette. It's in the pictures in the palette. Pictures palette.
Okay.
Down towards the bottom. And it's person. Okay? Are you feeling comfortable with that? Okay. Ladies and gentlemen, we're going to now do something radically different than what we've done. What we've done so far can be pretty familiar, but now we're heading in a different direction. To wit, we are going to add in a new agent called a city. Okay? Okay. And this city here, new agent type city with a capital C. Why capital? Because it represents cityhood, cityness, the set of all possible cities, the class of cities. It's not any one city, so we give it a capital C. Just like for color, we gave it a capital C for the class of colors. Okay? And in the terminology of what are called object-oriented programming, which is on what any logic is built, these are, in Java, is built to address, these are what are called classes. And we talk about there being instances of the class, particular cities, particularly people. Okay? So here's city. So I'd like you to double-click on city and open city here. Now, ladies and gentlemen, for city, I would like you to put in place a square of size 100, okay? And this square will be centered on this area here, which will mark its logical position. So we're going to go to Palette, and we're going to go to the visual representation of the palette. Do you see that? Do you see this visual representation area of the palette? It's got these kind of geometric shapes, platonic shapes, right? Okay. And we're going to draw again a rectangle. Ladies and gentlemen, and we are going to set it. We'll go down to position and size, and ladies and gentlemen, we will make its size, its width to be 100, and its height indeed 100 as well. Okay? Now, you can adjust this manually so it centers at that point, but you'll notice that what you can do is specify an X and Y here. I'm going to say minus 50, and I'm going to say for Y minus 50. And it will be centered at that point. Are we okay with that? Just like that. Are we okay? Okay. So we've drawn this rectangle. It's of width 100, height 100. Okay? And its X location is minus 50, Y location is minus 50.
Try to remember to build a lot.
Yeah.
Actually, if you build every time you make a change, then you'll know exactly where.
That's exactly right. If you build very often, it helps. There's fewer things which have changed, so if something goes wrong, you'll know with greater clarity what changed it. You'll have to undo less, at most, right? Okay. Ladies and gentlemen, so thanks to Alan for that. Okay. So now we've got our cities. Now, there's one final thing that I'd like to do just to deal with the varying sizes of these things, okay? And I'd like to go back to person, and I'd like to go to shape body within person. Do you remember that? How do we get there? What's one quick way to get there?
Do the project.
Yeah, the projects, we can expand person, presentation, expand person, go to shape body. And we're going to go to shape body, and we're going to set its scale X and scale Y to be 0.5. Where is that? Well, if you go to shape body, you could scroll down to position and size, and there'll be a 0.5 here. 0.5. Okay? That will be the scale. And that will make that person just a little bit smaller. Okay? Are we okay with that? Sorry? Oh. Up here? Okay, it's actually, I think you want to look at this guy. It's in position and size. It's possible it will need to be expanded. Yeah? Okay. Okay. So we're just setting up some basic visuals. Why are we doing this? Why do I deal with the incidental epiphenomenal feature of the model up front like this? Because if I don't, once we add the populations, it will be more of a pain to go back and tell it, oh, it now has a presentation, go add it in. There's a button to do it, but it's an inconvenient thing to have to go do that. So I deal with those things at first. Also, it gives us visual feedback. Ladies and gentlemen, visual representations, when I first came to this sort of modeling, I thought they were kind of eye candy. You know, fun, but not really that deep. Actually, some of the best insights I've gotten in these models are via the visual representation. Actually seeing it and seeing it laid out and seeing the dynamics as illustrated through the visualization clues me into a lot of what's going on. Much better than columns of numbers would spit out by the model. So while it may seem fun and games, it's actually a route to serious learning if you can invest in the visual representation of your model. It will also help communicate to stakeholders, to broader sets of individuals who are not modelers, but may be interested in engaging with the model and potentially providing feedback to the model. And one of the ways that feedback may be stimulated or elicited is you show them a visual representation and they can try to relate it to their own experience, their own observations, their own knowledge base. Okay? So they're not small things. Okay, ladies and gentlemen, let us go to main. Let us go down main. And let us add to main a parameter called, ladies and gentlemen, count cities. Okay? Now, I would note for Winchell and Allen that probably soon Ron will be joining us. So might want to batch up what I've been doing so we can quickly help him.
Or do you want him to just take your model?
Yeah, we could do that. It's probably a good idea. It's probably the best, most efficacious way to do it. Okay, count cities, and guess what we're going to do now? What sort of type will this be? An int. It's a count, right? And its initial value, ladies and gentlemen, will be 5. Okay. 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 Great. Okay, so now let's, ladies and gentlemen, I'd like you to add a population of cities to the model.
It's the default value, not the initial value.
Correct. Thank you. I stand corrected. That's the default value. And that's important because that's just the value if nothing else is specified. Who specifies the value of parameters like that in main? The what? For parameters in person, they'd be specified by a population or wherever we create the person. Parameters in main are defined by what? The thing that creates main is it's the experiment, the scenario, the experiment. Ladies and gentlemen, that's what will lend a value to count cities. So this 5 is just, if it's not specified by an experiment, use 5. But the experiment could use a different value. Yeah. Ladies and gentlemen, count cities. Okay, next I'd like you to drag in a city or create a population of cities. How do we do that? You tell me. What do we do? What do we do to create a population of cities? Yeah, drag city into main and call it cities. Okay? And is that enough to make it a population? What do we need to do? Make it a population of agents. And guess what the size of, how many agents?
5.
Indeed, but as mediated by what parameter? Count cities. Ladies and gentlemen, as a general rule, when you run experiments, if you want to put it, this point is one that I don't always emphasize, and I should. You want your model to be parameterized enough, and I'm using that term in a general sense, that when you go to make a new run with the model, let's say you want to investigate a certain intervention, or a certain counterfactual situation, a certain what if about, state of the economy in the future or what have you. You don't want to go modify the model to do that every time you want to do that. You don't want to go change the model, do it, and then change it back. That way, as Shakespeare said in King Lear, lies madness. Instead, what you want to do is you want to be able to specify it from an experiment. Each experiment, you can run the model with different assumptions. This experiment will run it with this intervention, this other one with that intervention. This experiment will run it with this future anticipation for economic, for unemployment rate or what have you. So the point is that we don't want to hard code in our model a certain number of cities and change it every time we want to investigate a different number. We want to be able to specify in our experiments, here 5 cities, and other experiments 10 cities, and just run the model with those different assumptions by having different experiments. We'll see how this can be done for interventions in a powerful way using dynamic parameters and action parameters. Okay, either later this afternoon or tomorrow morning. Okay, ladies and gentlemen, so here we're going to have count cities, and ladies and gentlemen, I would like to set those cities to be displayed at a certain point. Okay, and what will that point be? Well, ladies and gentlemen, let me show you a different way. You know what I could put here, right? What could I put here? Uniform zero to space width, right? There is another way to do it, which you should know about. You should be cautious about because it's not as general, it's not as powerful, but it's quick. It involves no code, and maybe for dealing with stakeholders, there's an advantage there. To do that, go to main, which is the thing that contains cities, and I'd like you to scroll down in main, go down main, down to the area called space and network. And now, there you could go down, you'll see something called layout type. Do you see that? Layout type? Okay, ladies and gentlemen, I'd like you to change layout type to be random, ladies and gentlemen. No less. Random. We actually saw this earlier today with ring. Do you remember I ran one of those models and they were in a ring? There's a bunch of layout types, including arranged, which is in a grid, ring, random, which is uniformly distributed, and spring mass, which is basically depends on network structure and will place people who are closer to network structure closer together. We're going to do random here. Can we run this model? Let us now run it. Build early, build often, make sure it's a happy camper, and run it. Okay? There we go. What do we see before us?
5 random cities.
Very good. Let's run it again. I'm going to make a point here. What do we see before us?
Same thing.
5 random cities. Let's run it again. What do we see before us? Same thing. 5 random. Random? It is random, but it's using the same assumptions about randomness, ladies and gentlemen. I think I mentioned this earlier in the boot camp, but but it bears note. By default in any logic, and I will criticize them about this, that they should really evolve this. The experiment is set to use random numbers that are based on what's called a fixed seed. What this means will be, given the same model, given all the same model and the same parameter assumptions, the model will by default run with exact reproducibility. And there are times where that's really useful. I would argue it's more common day to day that our needs are to run it with some variability, because we want to assess the variability, from time to time, especially for parameter variation experiments, which are set by default perversely to fixed seed, which to me doesn't make a lot of sense, particularly since they're often used to examine the impact of stochastics. So, ladies and gentlemen, we're going to change it to random seed, and let us run this now. Shall we not? Indeed. So let's run it. Now what do we see? Cities that are randomly distributed in different ways for different runs. Why? Because we changed it so now every time we run it, it uses a different starting seed and therefore a different sequence.
What is the random seed? It's under simulation.
It's under its randomness in the simulation experiment. And if you're wondering where does the random seed come from, after all, the random seed is used to get randomness going. Where does it come from? I believe it comes from the time of day in microsecond or milliseconds that you started running it, maybe something about the time and date, and maybe some other things like the machine serial number or something like that. So the idea is that it will almost never have any sort of repetition. The chance of you getting the same seed again is very, very small. Okay? Yes, Alan.
Here's a question. So if you specify the layout type, but you've also specified the XY,
Yeah.
you know which one takes precedence?
Yeah, so it's a great question. So ladies and gentlemen, the question was, suppose one goes in main and one says use random, but then you go to the population and you tell it to lay it out at a certain random point, between 0 and space width, 0 and space height for y, right? Which one? Well, it turns out this only applies here in the specified point. I think that only applies if it's a user-defined layout type. See that? These settings are applied only if the user-defined layout type. So the random layout that was chosen below actually overrides this. This provides a way of laying them out in a user-defined way according to these rules. So if I run this now, I would posit that it should still be random, and indeed it is, even though those said 0. Even though, ladies and gentlemen, this said 0 here. So really, we'll do it like this, and we'll just let it be at the random location. Is that okay? Okay. I'm going to save this model and post it. Okay. So this would be okay. And notice it mumble. It really shouldn't do that. Okay. Great. So, and I'm going to stop. So